All right. I just got the notice that we are now live. So I want to welcome everybody to the Data-Driven Approaches to Improving Traffic Operations session. Before we get started, just a few housekeeping items. There's a chat box. Please type your questions in the chat box and we'll answer them at the end of the session. There is a hard stop at 10:45. So when you're writing your questions, please include your email address. That way, if we don't get to them, our presenters will be able to respond to them. And then lastly, this is a time when I would normally ask you to silence your cell phones. You're all muted, so that won't matter. But please keep in mind just getting up and walking around in between sessions. If you're anything like me, yesterday you had a lot fewer steps on your Fitbit at the end of Roads and Streets than normal. So without further ado, I'd like to introduce our presenters. Dr. Yao John Wu is an associate professor of transportation and engineering and director of the Smart Transportation Lab in the Civil and Architectural Engineering and Mechanics Department at the University of Arizona. Dr. Wu received his PhD degree from the University of Washington, Seattle in 2010. Currently, Dr. Wu is the faculty advisor of the University of Arizona's Student ITE chapter. He has served as the principal investigator or co-principal investigator of over 30 national and international projects. Dr. Wu has more than 100 referred publications, including more than 50 journal publications. He has presented his research findings more than 100 times at national and international conferences and invited speaker events. Dr. Wu's research interests highlight a strong connection between information technology and traditional transportation research. He'll be joined by his colleague, Abolfaz Karimpour. Abolfaz is a PhD candidate and a graduate assistant in the Smart Transportation Lab at the University of Arizona. He holds a BS in Civil Engineering and a Master's in Highway and Transportation Engineering. As a graduate research assistant, he was the primary researcher on many national, regional, and local transportation projects. Abolfaz is a member of the ITE and has served as the secretary and president of the University of Arizona ITE student chapter. Without further ado, gentlemen, please take us away.
Okay, thank you, David. I'm trying to switch my screen to, sorry, I'm gonna need to look at my second screen. And also I cannot see how many people online. Do we have 100 people online?
I can't see either. I'll see if I can figure that out.
No problem. No, I just assume 100 people online. So thank you. Because today's schedule quite tight. I will try my best to go over what my lab has been doing, so everyone can get a big picture of my work. Especially, I should not say my work, my students' work. So I actually did not do anything. Everything is done by my students. Abel will talk about some research I've been doing. So let's look at the next slide. I'm controlling his computer. So first of all, I'd like to thank I have a lot of partners in Arizona. So I've been working closely with all the universities, and also let me click the next slide. Next one. Maricopa, Association of Governments, PAG, RTA, so City of Tucson, Pima County, City of Phoenix, ADOT. So all these projects actually supported by all these agencies. I do appreciate their support. As you can see, I put their logo quite big. They help me a lot with all this research idea development, and also in return, we want to make sure the research is helpful for them. So of course, the person I have to thank most, the people I don't thank most, are my students. That's our group photo we took during the summer. So during the pandemic, it's really hard to get people together. We did hold a party. So I ordered online food and sent to each of them their home. So we got a party together. So it looks like everyone's happy. Okay, so and today's presentation, I want to make sure everyone understand that university not only do research only, but for me, I really care about applied research. all the research in my lab has been doing has to be applied in the real world. So of course, I do use some equations sometimes, but I do want to make sure that all the equations we teach in the class, also we use in our research, can solve the real life problems. So that's things I focus more on, you know. And my research vision, actually, my research focuses are in 3 fields: data-driven ITS, sustainability, you know, transportation planning, safety. But I would say the yellow part is a bigger part for me. I'm gonna talk about several examples today. We have a limited amount of time, so I'll try to go over my projects and my research briefly. So hopefully everyone can understand what I've been doing. So this is the keyword cloud for all the papers I've been publishing. So you can see the travel traffic data is the key focus of my research. I publish a lot of papers about traffic data. It's not only data collection, data management, data analysis, and also, you know, data processing and prediction, a lot of things we do with the data. So I'm really excited about data. And all the projects I've been doing, you can see my clients usually ask me to do something about traffic, as you guys can see on the screen, the traffic and traffic data. So because today we're going to talk about traffic operations, I want to divide into 2 parts. Let's start with freeways, then we'll talk about arterials first. Of course, you can see ADA logos here. I'd like to thank ADA Tismo Division for their support to my research. We have been working close together. I've been doing several projects with them. Also, ADA Research Center also supported one of my projects too. I want to start with the data first. As I just mentioned, we've been working on a lot of data. So image data, the data we've been archiving is real-time, minute-by-minute data. We are the only place in additional ADA archiving the XD data. As you can see, TMC data has a lower, smaller coverage. And also in my lab, we're also archiving the 20-second data from the loop detectors. So that's why my first project actually has been working on, was focused on data quality control. So this video basically shows it's a tool we developed to handle the data quality issue for ADA. I don't think I have a lot of time to show all the videos in my presentation today, but I want to give you some flavor. So we developed a system actually can be running on in the real world and try to identify the problematic loop detectors. And as you can see, some of my slides today, I will include some papers. If you are interested in the academic papers we wrote before or we've been writing, so feel free to look for these papers. They probably can help you sleep better, fall into sleep faster. But in general, we do want to make sure my research can be beneficial to the DOTs and can solve real life problems. So this slide, I want to mention the recent project. I'm working with the ADA Tismo Division. This project, as you can see, is an expansion of my previous project from the REM metering evaluation project. This is a kind of like a phase 2 of the REM metering evaluation, because after the REM metering evaluation project, we found the system actually can be used for the network level. At the network level, we can actually improve traffic operations for the entire state. So that's why we developed a system based on the data we got so far. And then in this video, we're gonna see in this YouTube video, we will give you some flavor how we use the tool, how to interpret data. It's actually quite cool platform because this platform can do a lot of data analytics in real time. So it's called a smart tool. So if you are interested in this tool, please join us at ITS Arizona Annual Conference. I will be presenting this tool with ADA. We'll provide more details. So we optimize the database. We try to conduct as many data analytics modules, like analysis, as many as possible. And all the analysis modules developed by in this project will try to tackle real problems, try to see what ADA needs, and then we process data in a most efficient way. Again, we don't have a lot of time to demonstrate this module today because we have a really tight schedule today. So if you are interested in this module, please join us in the ITS Arizona annual conference. I'll be able to explain more about the smart tool I'm demonstrating right now. There are a lot of cool modules, so just no time to talk about. I need another 1 hour. So next time, probably I need 2 hours for this presentation. Okay, so next slide. Oops, that's great. So this slide, we recently published a paper. You can see it's a research because we usually like to extend what we are doing in the project and see if we can publish something academically. So this is one of the papers, Abel Fass, today's also one of today's presenters, published with one of my students too. This paper is published, actually not only presented at TRB, it was just accepted by one of the top journals, Transportation Research Part A in my research area. So this paper basically tried to try to investigate how much data is really required for conducting a RAM metering evaluation. Should we need to use 2 weeks of data to draw a conclusion? Should we use 1 month data to draw a conclusion? Can we just use 1 day of data to draw a conclusion? So this paper basically talk about how we think about this issue and in a mathematical way. So if you're interested, feel free to let me know if you have any questions. I can send the paper to you. After that project, that research, we also think, can we actually predict or estimate the statewide volume data? As you guys know, we are able to collect the volume data from the loop detectors in Phoenix area. So is that would that be possible to estimate statewide volume based on the INRIX data? As you guys, some of you might know, INRIX data only provides speed. So using speed data to estimate volume is not really easy. But good news is that I have smart students who work with me. So they are smarter than me, so they can figure it out. So we actually just finished a paper talking about how we estimate statewide volume using INRIX data. So if you're interested in the research, let me know. It's an ongoing project, so we should be able to present it fairly soon in the future conferences. So I'm glad I can move toward arterial. Okay, so I believe, let's go back. Abel, do you want to take it from here?
Yes, hi everyone, thank you, Dr. Wu. So let's start with the arterials. In the arterial section, we will discuss about a couple of things. First, we will talk about technology evaluation. What are the new technologies and what are we are doing in that aspect to evaluate the newer technologies. And then we will talk about the available sensors and the available technologies for data collection and data vehicle classification. As an example, in city of Tucson, in Tucson region. And then at the end, we will discuss, okay, we have these data, we have these newer technology. How are these data can be useful to do routine like transportation and traffic studies? First, let's talk about our first project. This project, we conducted this project, our team in University of Arizona, we did it for Arizona Department of Transportation. In overall, we evaluate the 3 main arterials, signalized arterials in Tucson, Nogales, and Phoenix region. We evaluating all these technologies, communications, signal communications, how they are reporting, they are operating and maintaining. And for this project, we developed a spreadsheet for ADOT. With this spreadsheet, with this tool, ADOT was able to find and maintain all their technologies installed at these 3 corridors. Following this project, we had another project for City of Phoenix. Mainly for this project, we evaluate 5 main ATMS in the Phoenix region: KITS by Cumulihorn, MaxView, Econolite, Transweek, and Tactics. It's important to note that for this project, We didn't say which ATMS is better or which one is doing better, but we developed a multi-criteria decision tool that will allow the transportation engineer and the agencies to input their needs and what they want into the software. And then based on that, it will provide them the better idea of which system they need to use. And our recent project with MAG, we are evaluating a new technology that they have installed in Chandler Boulevard and in Phoenix area. This technology is called No Traffic. It's an AI-based technology. It's able to collect traffic turning movement count. It's able to do classification, and also it's able to do signal optimization. It's based on a machine learning algorithm, and it's based on AI. So it's kind of adaptive signal controller, but they call it AI-based signal optimization because it will learn through the time, and then after the learning process, it is able to optimize the corridor or intersections based on the things that previous data that they collected. So far for this project, we have been evaluating the turning movement count. We collected video data, and also we went to the field to get some sense of how their sensors work. And we are working on this project to do signal optimization. This project is based on, we have two corridors in Phoenix area and Chandler, and we have more than 10 intersections installed with no traffic in Chandler and 5 in Phoenix area. Okay, now we talk about this new technology. Let's talk about what are the current smart sensors, what are the current technologies that has been implemented in the city. For example, let's take Tucson as an example. In Tucson, we have different type of smart sensors. The one that is mostly in city of Tucson is otoscope signals. They collect event-based data. Event-based data is the data that any vehicles, any pedestrians, anything that change at the intersection, if it turns green, if a vehicle passed, any actuation would be recorded. We have more than 500 intersections in city of Tucson that is enabled with otoscope, and it's directly connected to the max view. The other data source that we have is MyoVision data source. MyoVisions are smart sensors that is installed. They provide similar event-based data, and also they are able to provide more than 15 signal performance measures, such as arrival on rate, split failure at all the intersections that they are enabled. For now, we have 110 intersections installed with MyoVision in the county region. And the other systems, the other sensors that we already have, we have iris detector, we have wave and loops, and we have other type of sensors. But two of the most used and most important sensors that we have in city are MyoVision and otoscope sensors. So what did we do? How did we use these sensors in our project? How did we use them to improve the operation in city of Tucson? Our first project with city of Tucson, which is like a multi-year project. Now we are on phase 4. We are using data to retime all the signals, the corridors that I defined in our scope of work. As you know, signal retiming is a recurrent procedure. After 3 to 5 years, since the traffic pattern, since the demand will change, we need to do this project iteratively. So what are the steps that we do for signal optimization? As you know, the first step, we have an existing signal timing. So we go to the field, we collect data either from otoscope or event-based data, or even like from driving, from vehicle, prop vehicle. We collect the data. Based on those data, we will calculate performance measures. Performance measures could be travel time, delay, mobility performance measures at the corridor or at the intersection. And then based on the tools that we have, like we are using synchro and transync, we do the signal optimization, and then we will go to the field, we will fine tune it, and we will implement it in the field. And then again, we will do the process again every couple of years. And after data collection and performance measures, we will see if we were able to improve the corridor. One of these tools that we use for signal retiming is Transync. Transync is developed by University of Nevada, Dr. Tian. It's more like it will optimize offset for a whole corridor. As you can see, it's the vehicle trajectory going from these intersections. As you can see, it's come from here. It will go and it will show if the intersection, if the signals are good, if they are coordinated well with each other. This black line should not hit the red. Red means the light is red. But if it's well coordinated and we have a green band, it should be like this. When you move from an intersection, you should hit all the greens at all the intersections at that corridor. So based on this, we using this software for offset optimization. As you can see, not only we are doing this practical stuff for the city and we are optimizing their work, we are also doing some papers, some research ideas, which we had, like my colleague Shafan Lee and his group published 2 papers on this topic in one of the best journals in transportation, and they presented it in TRB last year. And now we have some examples of travel speed evaluation. As I mentioned, we have students, we go to the field, we will drive, and we will figure out the places that we mostly need to optimize, the mostly need to be improved. As you can see, this is one corridor, eastbound and westbound. We drive, we have like multiple rounds of driving on that corridor. And as you can see, all these darker areas are the locations that you experience bottleneck. So let's assume that you are driving from this corridor. It's based on 10, 20, 100 runs of vehicle. You can see that for all of them, the place which has a denser or it's darker, they are all those are the bottlenecks of that corridor. Based on this vehicle run, we will understand that, okay, these intersections are not running efficiency, or they need fine tuning, or we need to retime or optimize the signals on this corridor. We have it for eastbound and also for the westbound. These figures are developed by vehicle run through these 2 corridors. The next thing that we did, we were Pima County, 2 main corridors in Pima County, we optimized their signals. As you are all aware, due to the pandemic, this project was half done. So we were able to implement all these networks in synchro. We got the new signal timing and we implemented it in the site. But because of the pandemic, as you can see, the volume dropped significantly during March and April. So we are still waiting for the traffic to go back to be able to implement Transync model and optimize the corridors based on Transync. We use Synchro to optimize all these signals. However, the Transync part is still remaining. And we want to show how Transync and Synchro can work together, and either we can use one of them or we need to use both Synchro and Transync to optimize the signals. The next project that we talk about is about tech support for transportation network management system. This project is also done for Pima County. The main goal of this project was to see which intersections on the county level they need to have left-hand movements. Why left-hand movements is important? Why we need to have left-hand phasing? Left-hand phasing is important because almost 27% of all the crashes are happening at the intersections in the left-hand movement. And also, left-hand phase will improve the safety of the intersection. But how can we decide which intersections needs left-hand phasing? We have many warrants based on geometric warrants, volume warrants, and in these applications, in this app that we developed for Pima County, we are giving them, we are allowing them to automatically select the intersections, and based on the warrants that we develop for them, they will understand whether that intersections need left-hand phasing or not. And as I mentioned, we have like volume warrants, delay warrants. We already implemented volume warrants and speed limit warrants. We are working on the other warrants. With this tool, it will enable the technicians or the engineers in the Pima County to be able to select only the intersections that needs left-hand phasing. And also one more additional options that we developed for this tool is that it will allow the Pima County to rank their intersections. With this tool, they will select multiple 1, 2, 10, 20 intersections, and then it will automatically tell them which intersections are experiencing a higher volume, which intersections are experiencing a higher left-hand volume. And based on this report, they will know which intersection has the higher priority for them to go and check if the signal is working well or not. Okay, so I'll hand over to Dr. Wu, Dr. Wu to continue the presentation for the multimodal transportation.
Okay, thank you, Abel. So as you guys just hear from Abel, so my lab has been doing a lot of applications, data-driven research. So we just finished the arterial, but we're gonna move forward to talk about multimodal transportation. We actually did something really interesting. I'm gonna give you some examples because our time is limited today. So let me see. Okay, oops, one more slide. So this is one research idea we did. So we've been working in the city of Tucson. You know, as Abel just mentioned, that we have been working with them on signal timing, but sometimes, actually most of the time, we try to develop innovative ideas to see how can we help the city improve our traffic, not only mobility, but also safety. So one thing they usually would like to ask, us is that, do you know how much pedestrian volume actually is on a certain corridor? So we will try to see is it possible to use a controller event-based data to predict the volume, pedestrian volume. So my student developed a new approach. We are able to predict how many pedestrians crossing over location based on controller event-based data. So as you can see, we use a lot of video data to calibrate our model. And also, like Abel also work on another project, try to see if we can estimate pedestrian delay more accurately. So basically the approach is that we try to use existing data infrastructure, existing sensor, try to innovatively predict or estimate the new variables like the pedestrian delay and volume. So the process is not easy, but luckily my students are pretty hardworking. They figure out a way to answer these challenging questions. There's one project I want to mention is that we try to quantify Hawk-induced vehicle delay. I just thought something interesting I want to share with you during this project. We found something quite interesting. I want to show you the video so you can see the video here. I want to show you how people use Hawks cross the street. So you can see this passenger, oops. This person actually just got out of the car and tried to get out of the car and push the button so he can use the Hawk to cross the street, you know. And this another video also showed the same thing. There's another car. We call it byproduct because we originally wanted to do the Hawk study, then realized that a lot of people actually did something really interesting. You know, this car, the same thing. Even at night, sorry, the video is not in good quality online, but if you see the video from my computer, you can see the person, the driver, actually came out of his seat and go and push the button. So this, I believe, is a passenger actually push the button and come back to the car, and so this car can actually go through this intersection. Okay. So the student always find interesting, interesting to work on the transportation research. You can see something very interesting in the field. So in addition to pedestrian, we're also working on the research for bike sharing. We also did some research for e-scooters. Sorry, we don't have much time today to go over all the details, but I just want to show you we got a lot of data from the city. We try to analyze data. We also try to investigate, to analyze the riders' behaviors, the road user behaviors, to see where they go, where they came from. So it's quite interesting to look at this result based on the data. So as you can see, this is also another visualization. We can figure out where they get their bike sharing, the bike, and where they went to. So this is one example show the origin and destination of all the bike sharing riders. So because I want to leave some time for today, so this is my last topic for today is about safety. I know you just saw a lot of videos and figures, probably overwhelmed by a lot of things we just presented. So this is the last part about safety. So my lab also did some safety related research, and all the research actually done based on the real data. So sometimes we don't want to wait until the crashes to happen. So one study we did for the city of Tucson before, we actually did a before-after study for protective permissive left turn. Another study I'm going to talk about right now is the study we did for Piedmont County. This research basically is focusing on the speed feedback sign. We want to know how effective the speed feedback sign is, and should we implement more, or where should we implement the speed feedback signs? So this project basically talk about this. Of course, we also wrote at least 2 papers. So you can see a button, we present one of the papers at TRB annual meeting. So in conclusion, what ABOFAS found was that we need to use the speed feedback sign plus the random enforcement, so we can make sure that the speed feedback sign is effective. Speed feedback sign alone did not help that much in our study. So if you are interested, feel free to let us know. We can share the report with you. We also did another study to see how what's the impact of speed feedback signs on arterial operation and safety. That's another paper wrote by ABOFAS. This paper already published online, so I would encourage you to read the details. So we not only finished the report, in the meantime, we also try to write some academic papers to demonstrate academic contribution. Of course, I'd like to thank all these sponsors for their funding support. So with that, I know today we want to save some time for discussion. Sorry for going over all the details in a short amount of time, because we know we have the time constraints, and they're gonna cut off the video, the live stream 10:45 sharp. So I try to leave about 10 minutes for some Q&As. So I assume, David, you were gonna host the Q&A session?
Yes. And so, as I mentioned, please type it in the chat box. The first question that was typed in there is, will the pedestrian prediction methodology be publicly available soon? Pedestrian volumes are not often available, but can be very useful in traffic studies.
Okay, so let me answer this question real quick. So the algorithm actually already implemented online. I have the website, so the user can actually go to the website and to choose the date, the ranges they are looking for, and the system will automatically estimate the pedestrian volume automatically directly from the data source we have. So that already implemented. Sorry, today we don't have a lot of time. So next time I should request 2 hours of presentation, so I can show the live demo of that website. And for the what's the second question? Sorry.
It was just a follow-up, just saying how pedestrian volumes are not always available, but they can be very useful in the traffic studies.
Yes, yes, they are. And then one thing I want to mention is that because we use a mathematical model to estimate the traffic volume. So there's definitely an error. Okay, there's a error range. So it's not 100% accurate, so that's why in the paper we submit to TRB this year, we actually verify how much the error will be. So when you use the volume data, you're gonna know it's gonna be 10%, 20% error for certain locations. And moreover, you can see my student watched more than 200 hours of video to verify the results. So it's actually a really time-consuming process. Thank you.
And a follow-up that I had on that is you mentioned, Abelfaz mentioned a MAG project that was looking at an arterial corridor and collecting the turning movement and classification data and things like that.
Yep.
Was that also able to collect pedestrian data?
Yeah, the answer is yes, they can do it. But so the project we're doing is try to evaluate different types of technologies, so try to figure out how accurately they can collect the data. So for that specific product, they claim they can collect the pedestrian data. Yeah, there are many products can do it. There are many products can do it. So I just want to emphasize certain product. Yeah.
Another question for the speed feedback sign studies. Was there analysis of locations which only had enforcement but no feedback signs? So is it basically to determine if isolate the variables of enforcement versus sign versus the combination of the two?
Abel, it's your research.
For that study, we had 9 sites. 3 of the sites were speed feedback signs only, 3 of the sites were enforcement or periodic law enforcement only, and 3 of the sites were enforcement plus speed feedback signs. The overall results show that all of these enforcement, all of these speed strategies are effective in reducing vehicle speed and speed limit compliance. However, the sites with the speed feedback signs plus periodic law enforcement was able to make the drivers to reduce their speed more constantly. But the sites with the speed feedback signs and periodic law enforcement, the vehicles started to regaining their speed after passing those strategies. So your question is yes, we had sites with periodic law enforcement only too.
Okay. If I was wondering if you gentlemen could talk a little bit about how you're seeing COVID or the research that you're looking at shows traffic volumes being modified by COVID permanently, if that's a realistic idea or something that is, just curious what you guys' thoughts on that.
Yeah, Abel, you go first because you did this study too.
So for this study, actually the volume dropped. You're correct. The volume dropped when the pandemic started and when the stay-at-home order started. However, as you can see from the figures, this is for 4 months, actually, 3 to 4 months. The volume started to coming back. But one thing to mention is that maybe the volume goes back or maybe the volume is getting back to the normal. However, we are seeing some pattern change, like changing in AM and PM peaks. We are seeing different peaks during the day compared to non-pandemic time. But I think that's our takeaway from this project and from this topic. The volume is getting back. However, the traffic pattern might change later, like see different peaks during the day.
Right. And then one thing I want to add is that we got data. My lab has been archiving data from multiple cities. So we found different cities had different pattern changes. Like Marana, they have really interesting pattern change, which is different from city of Tucson's.
What was the pattern change in Marana?
If I remember correctly, because another team group in my team, they show me we can see the peak actually happen later in the day. So you don't see a morning peak. You actually see they actually go shopping and later in the day. So they probably work at home and then they try to grab something to eat, do some grocery shopping during their break time. you know, so the peak just shifted a little bit. Yeah.
Another question just came in. Do you know if the city of Tucson or other agencies will further look into the byproduct of the hawks? What other comments can you share about these byproducts?
Okay.
Do you think any needs should be done about it?
Thank you. That's a good question. So we accidentally caught those people, and then we actually talk about it, and the city got all the videos they can share with whoever they want to share with. So they haven't told me what's the next step for those interesting people. So I hope, you know, or probably City of Tucson can answer that question later. I'm not able to answer that on behalf of the City of Tucson. Yeah, I'll just share the information with them. And I also want to add, you know, doing our research, because all my research, I really want my students to explore themselves in the real world situation. So that byproduct is one of the byproducts we found. We actually did a lot of studies. For example, red eye browning studies. We did a lot of studies, and students actually found many interesting things you never thought about in your life. So next time, I probably can share some interesting videos. So we did find something really interesting. You never thought people would do something you never thought. Okay, so yeah.
All right. Well, I don't have any more questions, and I'm not seeing any other questions in the chat box. So I again wanted to thank you two for presenting this information. I found it very interesting. Thank you.
Thank you. I know we have a time constraint. 10:45 is a really, I try to speed up my presentation a little bit. So I like to apologize. I talked too fast. So if any audience, any of you are interested in knowing more about our research, feel free to email to me. So I list my email on this page as Apple just showed you. Feel free to give me a call. By the way, I'm not in the office, but you can leave the message and email me. I'll be more than happy to talk about any subject you. As a professor at U of A, I'm really excited about doing this type of research. Also, teach my students the real life traffic. Yeah.
So I actually just got another question that came in. You mentioned the SMART tool will be presented in detail at the ITS AZ conference. Will the tool be available for public use?
So good question. It's password controlled by ADOT. So come to that session, ask my project manager if he can share the password account to you. They make decision because they are my client. So it's password control. Yeah.
All right.
I think they will share, but it's up to ADOT. So
Understood.
Yeah, thank you. Yeah.
So thanks again, gentlemen. Much appreciated.
Yeah. Thank you, David. Thank you, everyone. Even I cannot see all of you guys. So thank you. Bye.
Bye.